we're very happy to be here. We're going to try and do something slightly differently with you, in that we're going to make you do some marketing plans for how to communicate to industry. So you've had some talks around the different types of communication. Ideally, we would have gone...
30. I think there are 30 of them.
Okay. Ideally, we would have gone after the talks that you have this afternoon, but Ed is an international man of mystery and is going off to Vienna tonight, so we've had to rejig.
Which is very kind of Alejandro to change things around. Thank you.
So we've picked a topic that we want you to consider, and it's around supporting the green economy using research infrastructures. Now, you may or may not know about the green economy, but...
Do you know about the green economy? Carl, you're young people, right? This is your future. You should know about the green economy. So who knows about the green economy? Let's try again. You're hopeless. Okay, they're hopeless.
So,
should we change the topic?
Well, we can change the topic. But think about, energy security, new methods of energy production, so batteries, fuel cells.
Construction.
Different construction
Aerospace,
methods. Yeah.
Sustainability, all that kind of stuff.
Don't worry, we will come round and we will help you with some of this stuff. So, this is the outline of what we're going to ask you to do. We're going to ask you to think about what are the key drivers for the green economy in Europe. That could take some time now.
It could. It's a huge area.
And then we want you to think about what resources synchrotrons and other research infrastructures have that can support industry who are trying to make new innovation in this sector. And then, importantly, how are you going to go about communicating that message to industry?
So this is based on what we do on a daily basis. So Alejandro, Nuria, Elizabeth, I, together with the other industry contact officers at Light Sources, go out doing this. So we try and match what we do at the Light Sources to what industry actually needs. Not what we can necessarily do, but what does industry actually need? And then how do we go out and communicating that to industry, large and small? And SMEs are especially a difficult target to try and reach.
Okay.
Yep.
So if you think about what industry wants from research infrastructures, this is, what we think after. I've been doing this for 25 years. Ed's been doing...
Less than that.
A little bit less. So
Yeah.
he is older than I am.
Tiny bit. 4 years. 4 years.
So there's various reasons why industry would come and use a facility like Alba, Diamond, Solaris. So maybe they just want some authoritative information. So what can we offer that they can't use on their lab facility? So they want something really key for their product. They might have a manufacturing issue and they just need a solution to understanding that problem within their manufacturing. They might want to just broaden their knowledge base. So this would be maybe more where they're funding students and postdocs, where they're trying to understand at a fundamental level what's going on in their area. They might just need some data to confirm results and theories, and this is particularly relevant now that there's a lot more modelling and AI work going on. You actually still need data to prove that your model is correct in many cases. And what we've found as well is that some organisations just want to show that they are research orientated. They're not just in it for the hard cash. So they want to show that they are research based and that there is science behind what they're offering as products.
So maybe we could chuck out a couple of quick examples in that list. Maybe one from the SRF is looking at the safety of lithium-ion batteries. Right, so you remember the stuff. You're still not allowed to take lithium batteries on airplanes in the holds, right? So you can't come back and carry stuff around. You have to carry it with you, and you get the warning message in the airplane. If your battery is smoking or catching fire, please do tell someone, because it's not a good sign, right? So one of the things done at the SRF was looking at how these batteries fail. So using high-speed tomography, filming the battery failing, and as a result, direct result of that, they have now introduced a safety vent to stop the battery. So it might still smoke, might still catch fire, but it won't explode. And that was one of the outputs. I think, Diamond, you've looked at tyres, trying to make
possibly.
Yeah.
Don't know about that one, but we did do batteries failing as well.
Okay.
But the research-oriented organisation, for instance, I've run some conferences in partnership with industrial partners where they just want to show, we are leaders in this field.
Yeah.
So there's many ways that you can communicate with industry. These are just some of the things that we do. So you've got your website, your social media. Think about your LinkedIn, Twitter, not so much the Facebook, etc. Case studies. So showing what can be done, communicated in the language that industry understands. So not your scientific paper that goes into all the detail about everything. It's like, what was the problem? What did we do? And what were the benefits to industry? So really simplifying it down, but talking in their language, not our language as synchrotron experts. So that's something that, think about that. PR activities, so joint press releases, that kind of thing. Exhibitions. So these guys were over in Granada a couple of weeks ago
Very nice.
at a big exhibition where we were talking to industrial suppliers rather than industrial users. And then conferences, so participating in scientific meetings and talking to the industrial participants.
But as you heard earlier, sorry, go on.
And other things, yeah.
Yeah, as you heard earlier on, Elizabeth and I are quite sort of old, and you're all quite young. So there's a ... there. So if you come up with other ways of communicating when you get to telling us what your plans are, don't hesitate to be imaginative and creative, right? LinkedIn is very old-fashioned. It's old school.
Yeah.
An exhibition is a bit dull. So there's other stuff to be done there.
Yeah.
We need some ideas as well, right? So we might actually go out and use your ideas in the real world.
Yeah. So this is what we would like to do. First off, we want you to split into 6 teams of roughly 5 students in each team.
Your choice who you work with.
So,
but think wisely, because you need to be with the good ones, right?
So that's the first thing to do. And we're going to put you in 5 different, 4 places in here and 2 groups outside. So if you can first off make your teams, give your team a name, share what level of marketing knowledge you have, if any, and share what knowledge you have of the green economy, if any. And the lecturers there are some lecturers and other participants in the room. We encourage you to move around between the different groups and share your experience.
We probably need to tell them what they're letting themselves in for as well, I guess, because we're going to gradually we are going to gradually reveal what you're doing, right? We're not showing you everything here, but I think it's fair to say there's an end moment, right, Elizabeth?
Yes, at the end, you're going to have to pitch your idea to some judges here, and the winning team will get some prizes of some
exciting
synchrotron goodies.
Worth fighting for.
So think very carefully who's in your team and who's going to make your presentation at the end.
But the pitches are US style, right? So it's 3 minutes max.
Yeah.
To pitch what your ideas are, what you would do, right? Again, don't be afraid to be creative. It's okay. There's no wrong answers, right? It's the ways that you would try to work with industry and telling us what you would do with a particular industrial sector, okay? So we're going to take you through the different steps. Do we need to, because they're going to split up and go into different parts of the world now, do we need to actually just tick through it, or?
No.
Nope.
Just get into your 6 groups for now and come up with your name and just have your little discussions in the corners of the room, and then we'll move on.
Okay, cool, because some of them are going to be outside, right?
Eventually.
Okay.
Dragon's Den. I'm not even going to try and pronounce all of those variations of Dragon's Den, but we know that it's in all of your countries, so you should be familiar with the concept. I'm not sure which of these guys is Deborah Meaden in the middle there, but you know.
I'd like to be Peter on the far right.
Oh, he's got lots of money.
He's my favourite dragon.
Okay. So we're going to bring you up here, group at a time. You will have 3 minutes. We are timing you. Present your ideas, and at the end we will make a very non-scientific judgment of which we feel is the best idea communicated. Yes.
So the people you're pitching to are Alejandro, Piotr, and Mikhail, and Elizabeth and I. Okay, we're going on gut instinct. For me, it's would I give you the money to do what you want to do? But each of the other people here may have different flavors of how they feel about your pitch. So you're going to go in a random order with a very sophisticated picking system. Who can I'm going to... So we'll start the timer. And first, do you want to pick? Can you get in there? Yeah, one of them. Do you want to open it up? So I'm not doing it, right? It's independent. Can you read my writing? Probably not. Solbar. It's you guys, right? Okay, I can get the bin. So you've got 3 minutes from when you tell us to go.
No, from when we tell them to go.
Wow, it's going to be nice. Have you started yet? No, arranging themselves. Okay, are you ready?
3, 2, 1.
Oh.
Okay, they failed the first part.
Okay, we're ready.
You good? Okay. Go. Do you need a mic?
Okay, our team name is...
Yeah, okay,
Stop.
we'll give you
Okay.
extra time for that. It's okay.
Okay.
Hola. It's fine?
Yeah.
It's not on.
Hola.
Ooh, microphone's too close.
Hola. Okay. Let's start.
Well, we'll start your timer again.
Okay, let's start. Okay, our team name is SYLINDA. So it can be understood in two parts, SYLINDA. Sola means solar rays, because our team members solar rays, and the other one is ALBA. Okay, and solar can be also understand solar is the sun, and let's use the sun. So, and we are, in our team, we're thinking use the sun in two ways. First, solar can be also similar to salad. So it can, which means we can eat in a green way. And also it means could be also solar energy. So for the so for this part, for the food part, I mean, we can use the synchrotron to help to detect the nutrition elements and also to guide us how to grow better food and more healthy food through better fertilization, like these things. And for the solar battery part, in the synchrotrons, we can help to discover new materials which can be used in the future for the solar batteries or solar panels. And also in the current studies, we can also use the synchrotrons to help to improve the lifetime or efficiencies of current materials. For example, perovskites usually should. Now, the main issue is the lifetime. In synchrotrons, we have a lot of surface science techniques which can be used to study the surface properties and also to do surface treatment to improve these things. So, to summarize our team, the main core information is we are going to use the sunlight in a green way. We either eat green as a vegetarian lifestyle, or we harvest energy in a green way through solar energy, through solar batteries, new materials. That's all. Thank you.
Oh, very good.
Seems too fast.
So dragons, you can now pester the contestants if you've got any questions.
So why synchrotrons? Synchrotrons are expensive. It doesn't make sense. We have many normal labs where we can measure materials.
Yes, but I mean, because I'm from physics world, so and also from the material science, so I can answer your question from the material science aspect at least. For the material science, most of the new materials, once they are synthesized, and you can use the synchrotron to study, say, electronic, magnetic properties, and all properties, all structures in the synchrotron in a much, much faster and efficient way. In this way, you can improve or you can speed up the discovery of new materials instead of normal setups, which is slower. And also in the synchrotrons, you can do a full around all aspects of studies of the new materials, electronics, magnetics, structure, and everything. So in principle, I would say in a synchrotron, it can speed up the discovery of new materials much, much faster. This is from the material science, probably, I don't know, from the food or biology part, I don't know. I mean, I don't have this background, but probably you could also do similar things. Okay.
Alejandro?
Yeah, I have a question. I mean, because the applications are very broad, and that you're thinking in a more specific application of your solution?
Yes. Not new applications, but we are thinking because we have already some supporting cases. For example, for the more healthy food, because as vegetarians, we know that, especially if you take a vegan lifestyle, even though you can reduce the energy you consume, but in another way, you may lack of some nutrition. So you need to supplement some additional pills. But for this, probably in a better food system, we can help to guide the growth such that the food contains all the elements. For example, the very example is the selenium mushrooms. It can be, for example. And also for the materials, as I said, the perovskites. The perovskites is now it has the solar battery. Solar battery material which has the highest efficiency, but it has a problem of lifetime. So in order to improve the lifetime, people try to, for example, do surface engineering these things, or these things. I mean, the surface engineering means surface science, and in synchrotron we have a lot of surface science techniques which can be used to address these issues. And also to discover new materials. Also, this is something very common in the synchrotrons, especially, for material science. So this is already some very concrete examples. And for new applications, I think it's not a big problem.
Have you identified any industry or that could be interested in your solution?
Sure. These two aspects are all very strongly related to industries. For example, the food and the vegan and also the vegetarian things. There are a lot of new companies or startups trying to sell this kind of products to the markets. It's a very big growing market nowadays because of the climate crisis. So people are trying to promote this vegetarian or green lifestyle. And for the energy, also it's a similar idea because now the energy price is increasing. So people are trying to seek for new energies. For example, the green energy like solar is very common, and one of the motivation or one of the effort is to find new materials and for solar batteries.
Okay.
So it's
Thank you very
there
much.
are very big markets behind these things.
Okay. Thank you. Well done. So the next team is Green Team.
That is indeed you. It's your style. You do what you want to. You probably need a microphone. Did they steal the mic?
Thanks.
3 minutes starting from whenever you start.
Hello, we are the Green Team. Mother Earth is like a machine that needs good maintenance, but to keep it running for longer times, we have to think about how we deal with our these days products and how to deal with pollution and so on. So our main goal is having some kind of circular economy with bio-based products coming from side streams.
Yeah, so as my colleague just said, we don't want to pitch to you a certain product, but merely a holistic cycle, a holistic picture, if you will. We created it here as something of a circle or a gear, if you want to pick up on the machine metaphor. And our idea is to use like, for example, byproducts or energetic side streams, and then to interconnect different companies with one another to show those companies how they could benefit from one another. And also, on the other hand, to connect companies with research, because our idea is to use for example, and most importantly, synchrotron radiation to check the new so-created products for example, stability or to ensure homogeneity in the product itself. And therefore, we think of it as one gear that we want to apply on each company and finally to interconnect all companies on the whole world with one another to keep the machine running. Do you want to say something, so?
Yeah, great.
Okay. Yeah. Maybe you can answer the questions.
Questions?
So you've talked about holistic cycle. Where is money in that?
So we think about us like a startup, but we know that there's also many opportunities for the grant, for the co-working between research and companies. So we would like to use these monies also, and we would like to also show these opportunities to assess this money to companies. And I think that research institutes mostly knows about it, but to join this, to get this money.
Your aim here is to create like a startup that is proactively matchmaking industry with the research infrastructures.
Yes, we would like to have like a basis of the companies and research institutes and combine this and combine also companies between them.
Do you aim to be a not-for-profit or are you going to make money? Because you're coming from a very sort of holistic, friendly sort of approach. Are you actually hardcore capitalists or are you out to save your work?
Well, let's say it with the startup mentality. The money is within the industry. So the industry has to think about their chances of getting new products from their side streams. So there the money comes from. And if you think about pollution, when we lose our Earth, then there's no money anymore. There's no people anymore. So how would you monetize it? So just think about our future.
A little bit of both, maybe. Yeah. Surely we want to save the world and to combine the world to make the companies and research work as a team, as one machine. But on the other hand, for sure, money is always a factor.
Yeah, we would like to survive on this world also, to make it better.
Yeah. What could be the main application or the main sector, industrial sector that you are thinking of for the application of your solution?
Could you repeat the question?
Yes, the industrial sectors that you are focused in for application of your solution. The main one, let's say.
Yeah. In our examples that we thought of, we mainly were thinking about, for example, the food chain industry.
About, sorry?
The food chain industry. Like, for example, we had examples of corn industries and how we could use those byproducts, for example, with starch or, what else, with the wood industry to use byproducts of this one, for example. We also thought about the importance of those cycles not competing with each other. For example, we had the idea that we don't want to use products that can be used as food, for example, like corn, to produce plastic. We would like to be very careful in that scenario to not compete with one another, but to work with one another.
It's not a question, it's just a suggestion that I think that more or less everything can be eatable. So I think if you would go in that direction, that all the garbage in this we produce in this world to transfer it into something that we can eat, finally, that would be perfect.
We talked about this as well, and we also thought that in a lot of cases, wastes that are produced, especially in food chain industry, don't need a lot of processing to further use it as, for example, feed for animals or something like that, or food, if you will.
Wonderful. Thank you very much.
Thanks.
Need to turn your mic.
Green muffins. I don't know where you're. Okay. You're up next.
O, mamy już?
So you can stand there. Up your choice, right? It's on. It's on. Check my red light's on. Minutes from when you want to start.
Think art, synchrotron art. Admire the beauty of science, because is it Arpus spectra, refraction patterns, or proteins? They are as majestic as the Mount Everest. We make them accessible to you. We present them you via exhibitions, prints, auctions, fashion.
Yeah, but are you on TikTok?
Sure we are.
We got your attention? Okay, and now we are from Synchrotron, and I think if you are developing new materials, you are from food industry, you are from, you're working with waste materials, we have the answers from you. For example, we are covering German and Poland market, and you are from chemical company like Grupa Azoty, and you produce a lot of waste, for example, chromium-6, and you would like to know what to do with it. So we can help to understand for you what is going on with this chromium-6. How, for example, bioweathering can help to invert this chromium-6 to chromium-3. And maybe if it will be algaeous, then you can eat it. If you are working with catalysis, for example, and you would like to see what is going on with this catalysis through the whole road of the production, we can make in situ experiments for you. If, for example, you have some kind of pollution in water, like it was in Odra river last time, we can answer the question how you can clean it. And also we can tell what you can make with the waste materials from energy plants. For example, zeolites can be used for cleaning water, for cleaning soil, and so on. If you are from food market, like for example Oshi company in Poland, we can help you to control the raw materials which different suppliers gave to you. For example, we can see by our techniques, we can see what other techniques can see. So we have the answers for you. Come to us and we will help you.
And to close the cycle, you will not only get your results and your answers, but also a beautiful piece of art. Thank you. Buy it.
May I talk? Yeah. Do you have any nice example to show us that where all this nice marketing can be proof? Yeah, nice example. I mean,
Yes, of course. Let's say, for example, you are Grupa Azoty company, yes, and you produce in your producing chain, you have a chromium-6, and you store all of these materials in a big pools. And actually, you would like to know what you can do with this chromium-6. You can't just put it to the Odra river and then let's make the fish alive. Yes, that is why you keep it in the pools. And let's say some algaeus can transfer the chromium-6 to chromium-3. Yeah, and actually, the only one method how you can control it is using X-ray absorption spectroscopy. You just gave us the sample before and after this so-called bioweathering, and we will show you. We will give you the answer in 15 minutes. And according to what Piotr can tell you, the price will be not very high.
then we can supply you with, let's say, a beautiful piece of art made of your results. Something that you can sell further, show it in the media. So you can actually have both.
And imagine that, for example, some kind of a child comes to his father and asks, instead of Marvel T-shirt, Father, I would like this beautiful T-shirt with the X-ray absorption spectra.
As you do.
I have a question. How much money do you need, and how would you spend it?
Actually, one of the main ideas of this Think Art is to make some kind of exhibitions based on these scientific results, and we would like to invite some kind of famous and not only famous artists which can help us to convert the beauty of scientific data to some kind of a piece of art. Let's say Barcelona is very known by Gaudi's by Gaudi magnificent architecture. He took the beauty of nature into the architectural buildings. Why we can't make it with the scientific results and to make such kind of a beautiful, let's say, statues or let's say pictures, yes? And then we can sold them also for some kind of auctions and get some money. Why not? Maybe millions of dollars. And then we can use it for developing of our infrastructure. Why not? Let's make science popular.
So how much do you need to start?
I think we are on a very good base because we already have synchrotrons, and what we need to do is it's a quite low budget. Let's say 1 million euro for Alba and 1 million euro for Solaris. And if we are if we are on a good road, we can give you answers for your questions, and also we will give you a piece of art.
Yes, and don't forget about other synchrotrons like ESRF and.
That's a good point.
Yeah.
Yes. 2 million.
Actually, yes. Excuse me, please. Then for SRF and for Diamond, because they are bigger, for 2 million for each of you.
Thank you very much.
Well,
thank you.
Thank you.
So our next group is SUSCAT.
Yep. That's this guy's over there. Sorry. I'm on. Okay. 3 minutes from whenever you're ready. First word.
Hello, sorry. Now?
Yeah. Go for it.
Hello, Dragons. We are aiming to aid the automotive market to reduce the cost of the catalyst. Currently, most of the catalysts used in automotives are based on platinum or palladium or very expensive and metals with a little abundance. And that, of course, is not profitable for a lot of, it's not super profitable for the automotive market. And what we will present is a way of using high throughput reaction experiments coupled with machine learning to develop new catalysts based on iron, on cobalt, on copper, that are way less expensive, and that way, and also less contaminant, and that way we could reduce the cost of manufacturing cars. And the way that we would approach it is by having a PhD student, for example, which we would train into the techniques and also in the analysis of the results. And that way we would have everything included, so not only giving you the results and that's it. So, but also doing the analysis, which is also which is usually the worst part. And so our project will be that trying to develop new materials with a higher efficiency and less cost, using more abundant metals. So that's our pitch. It's very
Thank you very much.
have a question. So, how are you going to market this service? What methods are you going to use?
We could try to do an initial test and publish it in some like easy to access journal, just showing like a proof of concept that it can be done, and then try to maybe contact universities that have already collaborations with companies, with automotive companies, and sell them, or explain them that we can do this. Maybe they are interested. We could maybe even do a collaboration between the university and the synchrotron, and have the PhD student doing like some part at the university or at the company, and also internally in the synchrotron, do the test there. Yeah.
Yes, so one question. Well, the automotive combustion machines of automotive are fading out. So are you thinking in another alternative application or your solution?
It's true for cars, but also we have to think maybe about planes and ships, that it will take a lot longer to phase out combustion motors. So even if cars disappear, let's say, no cars, but combustion cars disappear, the ships and the planes still need to use oil. So it could be marketed that way.
Thank you.
Dragons are silent. I think, because you be mentioning, have you thought about the hydrogen economy? Because you mentioned ships and higher transport.
Also,
right?
one of the things that could be done is, rather than just doing catalyst for combustion, also try water splitting, or just to generate hydrogen, and that hydrogen use it as the fuel. Yeah, of course.
Okay.
And also the chemical industry, right? They need catalyst, right? And this. Okay.
Yeah.
Are you thinking on that? Okay.
Catalysts aren't going to go away, that's for sure.
Yeah, it was more focused because maybe it's easier to sell it if it's more focused in one industry than try to scatter in a lot of them. But yeah, of course, catalysts are used everywhere almost. Yeah. So all the industrial processes use catalysts at the end. So yeah.
Dragons are done?
Yeah.
Excellent. Thank you very much.
Thank you.
So by default, the last one's up, our green circle. So when you're ready, 3 minutes from the first word.
Thank you. Okay, hi, thank you. In our case, we are focusing in a specific problem, which is the generation of mine waste. Mine companies, when they remove the metal of interest, let's say, from the soil, they also generate large amount of waste. Thank you. Large amount of waste, which are returned to the land, and it's growing and growing in time, and also concentrate in contaminants or useful metals. So it's not only a problem from mine industry, it's also a socioeconomic problem for the governments too. So the idea of this green circle project, let's say, is how to revalorize this waste material, which means they remove the metal that they are interested, but there are other metal or components also of interest, for example, to make superconductors or other electronic materials. So how to collect these? Well, it's not the same, for example, having iron 2 or iron 3. You will use different methods to recover one on another. But with your ICP-MS, how will you know which one do you have? Difficult, right? So synchrotron facilities has the infrastructure, the techniques, such as SHAS, and the personnel to understand this and give you the information. So Green Circle does not only do that, they will give you, or we will give you in this case, extra knowledge in research and manpower to understand this and to try to choose the best way to recover the material. How? Well, apart of the manpower and the facilities, we can also offer management plans We can give you agreements between the industry and university, for example, and also funding opportunities, because it cannot be only in the back pocket of the companies. It's not only a problem of the industry, it's also a problem of the social people, and good for European Commission, for example. You want to continue paying, China for the material or Russia? No, you want to have your own sources, okay? So this will be a way. Another part will be, of course, the marketing, which will be giving the social impact information, reaching more industries, mine industries, or putting in contact the mine industry with the last users, who will be the superconducting companies, and so on. So I think the overall information will be like the mine industry can solve a great socioeconomic problem with the help of the synchrotron radiation facilities and techniques. And I think that's all.
Brilliant.
In a summary.
Very good.
Questions?
I have a question. I mean, your idea, your project is to found one company to manage all this activity, or how do you plan to, let's say, to implement this solution? I mean,
well, it can be in several ways. One way can be find companies that are interested. So Green Circle can be kind of the center of the university, of even ALBA or other synchrotrons. Can be kind of the management people in the middle that put in contact all the industries. Mine industries in Spain, there is a lot, in the south of Spain, mostly. And also in France, there are a lot of companies, or South America, so it should be someone that put all these people in contact, going to events or other ways of marketing.
okay, and let's say, have you identified some companies that also might be interested in your project? I mean,
Yes, in our research group,
Yeah.
we work with some mining companies and other analysis companies, and then there is a company that kind of take all the residues and share it to all the partners, and also centers like universities. We also collaborate with universities, and there is a company kind of in the middle, putting everyone in agreement, which is the hard part, to be honest.
To create the consortium.
Yeah.
The basis of our company is to create a consortium between all this, between the industry, between the university, between the synchrotron, between the final recipients of the new products generated from the waste. And we are the center, and we try to make the team building of all these.
And who puts the money?
We can, because we talk about that it's not only a problem from the mining company, it's also a social problem, an economic problem. We can take, we try to apply for money from the government, from the European Commission, and also from the mining, and also from the final industry that are going to receive this new product generated from the analysis.
Now for European projects, they ask you to be in collaboration with companies. So it's kind of, depending on the project, they say you need 2 companies. It's like, we are a university.
And is it a profitable project or company? Do you think that the company working on that, or the consortium, will make money?
Yes, if
Why?
you know the process, like the right process, you can recover, for example, iron, gold, copper, and so on. If you don't know the species, you can do trial and error, which will not be profitable. But if you go to SHAS and you know which speciation you have, you can target the specific methodology to remove it, only your metal of interest, and try to do a chain. Of course, there is a lot of involvement of different industries here. The people that do the pilot plan, and they are experts on that, how to recycle even the water. You can recycle the water inside the pilot plant. You can do a lot of things that, of course, is outside of our lab of expertise, but the industries are usually, if you have a good project manager, of course.
So would you be aiming to take is it a pay for service, or would you take a percentage of the gold that's being recovered, for example? What's your business model?
Yeah, the first idea is that the project needs to be auto-sustainable. So you cannot waste more than you are going to earn. So first part would be, can you recover enough to make the process auto-sustainable? And after that, you can ask about more. But in theory, yes, it depends of how do you develop this kind of group. If you are a university, you can run projects If you are a company, of course, if this is developed by the mining company, they are already taking profit. So, in theory.
Are you cooked dragons?
Yeah, thank you very much. Thank you, all of you. So we're going to have a very quick huddle.
A 60-second huddle.
Decide who the winners are.
You can say something as well.
So, after a prolonged
discussion
here, we'd like to praise all of you, actually, and really thank you for participating and putting your energy into coming up with these ideas. It's the first time we've done something like this, so thank you for actually participating and making it fun for all of us.
Yep.
But there can only be one winner, and the winning team is what they're called?
That one there.
Green Circle. So, well done.
So you have to come up the front. You can be the presenter. I'll just be the bagger.
So thank you very much to Alba for the prizes.
Who's the boss?
There's one there.
There you go. Oh, go. There you go.
Oh, there we go. Teamwork.
Thank you very much.
Well done.
Yeah, you should have a winner's speech.
Dear candidates, we can contact more details after this section. Okay. We are very happy to serve you more opportunities. Okay. Let you make more money. Okay. It's not a dream. We are serious, not joking.
Now that you have the money, you have to implement the project. So you have no excuse. So that's important, okay?